If you traveled 250 million years into the past, you wouldn't recognize Earth at all. This wasn't the world of giant T-Rexes and towering sauropods yet. Instead, you'd be entering the aftermath of one of the most devastating events in the history of life. A moment scientists call the Great Dying, the Permian-Triassic extinction. At the end of the Paleozoic era, nearly 90% of marine species and 70% of land species vanished. Entire marine ecosystems collapsed, forests disappeared, predator-prey networks shattered, and the planet entered a long, uncertain recovery. But every extinction also resets the evolutionary meta. And in the Mesozoic era, that reset would eventually create the Age of Dinosaurs. Welcome to the beginning, the world after the Great Dying. To understand the rise of dinosaurs, you first need to understand the world they inherited. Earth's continents were fused together into a single supercontinent known as Pangaea. This enormous landmass stretched from pole to pole, and because the interior was so far from the oceans, much of it was brutally dry. The climate oscillated between extreme humidity and aridity, creating unstable environments across both terrestrial ecosystems and coastal regions. Adding to the chaos were massive volcanic eruptions known as flood basalts. These eruptions release staggering amounts of carbon dioxide, CO2, into the atmosphere. The result? Severe global warming, acidifying oceans, and unstable weather patterns that continued stressing already fragile ecosystems. Life wasn't thriving yet. It was rebuilding. The Triassic period begins. This chaotic recovery phase marks the start of the Triassic period, the first chapter of the Mesozoic era. The Triassic is typically divided into the early, middle, and late Triassic, and each phase tells a different part of the story of life's comeback. In the early Triassic, ecosystems were still dominated by survivors from the Paleozoic. One of the most successful groups were the synapsids. These included creatures like therapsids, dicynodonts, and the famous Lystrosaurus, an animal so widespread that fossils of it have been found across multiple continents. Lystrosaurus was essentially the ultimate survival build, a sturdy herbivore with powerful digging abilities and high environmental tolerance. In a world recovering from mass extinction, that build was incredibly effective. Other synapsids like cynodonts and diademodon also filled important ecological niches, and some of these would eventually evolve into the first true mammals millions of years later, the other reptile faction. But synapsids weren't the only players in the game. A rival faction known as the sauropsids was expanding rapidly. This group included archosaurs, the evolutionary lineage that would eventually split into crocodiles, pterosaurs, and of course, dinosaurs. Early archosaurs weren't particularly impressive at first, but they possessed one trait that would later prove game-changing: upright locomotion and posture. Unlike sprawling reptiles, these animals held their legs beneath their bodies. This improved stamina, speed, and overall mobility. Over time, this advantage allowed them to explore new ecological niches. And eventually, one lineage of archosaurs would evolve into the first dinosaurs. Life in the oceans. While the land ecosystems were rebuilding, the oceans were undergoing their own evolutionary experiments. New marine reptiles began appearing. Creatures like nothosaurs, placidus, and the long-necked Tanystropheus dominated coastal waters. Some species, like Atopodentatus, developed bizarre feeding strategies suited for scraping algae from reefs. Meanwhile, fast predatory fish like Bergeria americana patrolled open waters. And slowly, fragile reef ecosystems began to recover with the return of scleractinian corals. This period is sometimes called the Coral Gap, a time when coral reefs temporarily vanished from the fossil record before eventually returning. Ocean ecosystems were rebuilding from the ground up. Amphibians hold the line. Back on land and in freshwater environments, amphibians remained important players. Large temnospondyls, such as Mastodonsaurus and Plagiosaurus, dominated rivers and wetlands. These animals functioned as ambush predators, lurking in shallow waters, waiting for prey to wander too close. Meanwhile, a much smaller creature appeared during the Triassic, Triadobatrachus. Often considered a stem frog, it represents an early stage in frog evolution. Even today's frogs can trace their ancestry back to these early amphibian pioneers. The rise of insects. While vertebrates were slowly rebuilding ecosystems, insects were quietly but dramatically diversifying, laying the groundwork for ecological complexity that would last millions of years. Among the major groups, Hymenoptera, the ancestors of modern wasps, bees, and ants, were evolving novel behaviors that allowed them to exploit new ecological niches. Some developed primitive social structures, forming colonies that could defend nests and coordinate foraging. These small, unassuming insects were already becoming ecosystem engineers. Coleoptera, or beetles, began to expand into countless niches, from scavenging decomposing plant material to preying on smaller insects. Their hardened elytra, or wing covers, gave them extra protection, letting them survive environmental hazards that would have killed less armored insects. Diptera, the early flies, were starting to appear in freshwater and terrestrial habitats. Many of these species would eventually become pollinators, decomposers, and even parasites, influencing both plant and animal populations. And then there were the early Lepidoptera, the ancestors of moths and butterflies, which likely fed on spores, pollen, or soft plant tissues. Though not yet the spectacular pollinators we know today, their presence hinted at the coming intricate relationships between insects and plants. These insects were far from passive. They played crucial roles in ecosystem recovery, pollinating plants, decomposing dead organic material, controlling populations of other invertebrates, and even engaging in parasitoidism, a reproductive strategy where larvae grow inside host organisms, eventually killing them. It's brutal, but highly effective, giving insects a competitive edge in the race to dominate terrestrial ecosystems. In essence, insects were quietly reshaping the rules of survival. They were laying down the invisible scaffolding for the complex food webs that dinosaurs and other vertebrates would eventually inhabit. Without them, herbivorous and carnivorous species alike would have lacked the ecological balance necessary to thrive. Plants rebuilt the world. Of course, none of these ecosystems could exist without plants. The Triassic landscape was vastly different from the lush forests we're familiar with today. The dominant flora were gymnosperms, seed-producing plants that reproduced without flowers. These hardy survivors included towering conifers, which provided shelter and food for herbivorous vertebrates, and ancient seed ferns, whose leaves were rich in nutrients. Dense growths of horsetails and club mosses carpeted the forest floor, providing both cover and food for smaller animals. Closer to the damp soils of rivers and marshes, liverworts and mosses spread, forming mats that stabilized the ground and maintained humidity in microhabitats. These plants weren't just passive scenery, they were the foundation of early herbivory networks, directly influencing what animals could eat and where predators could hunt. With insects helping pollinate some species and decompose plant matter, and herbivorous animals browsing or burrowing through vegetation, a dynamic balance between herbivory and carnivory began to emerge. Ecosystems slowly regained their complexity, species diversity increased, and the groundwork was laid for the next evolutionary explosion, one that would eventually see dinosaurs taking center stage. Life was rebuilding itself, piece by piece, from microscopic insects to towering conifers. Every organism, no matter how small, played a role in restoring Earth's intricate web of survival. The Carnian pluvial episode. But the Triassic still had one more twist to throw at life. Around 234 million years ago, Earth experienced a dramatic climate shift known as the Carnian pluvial episode. This period brought intense rainfall across much of the planet. Regions that had been arid deserts suddenly experienced prolonged wet conditions. These environmental changes triggered a new wave of adaptive radiation. Entire groups of animals began evolving rapidly to fill newly available ecological niches. And among those groups were the earliest true dinosaurs, the dinosaur build. At first, dinosaurs weren't particularly impressive. Most were relatively small, but they had a few key advantages: efficient upright posture, improved locomotion, and lightweight skeletal structures. This allowed them to move faster and more efficiently than many of their competitors. Over time, this mobility advantage allowed dinosaurs to spread across a wide range of habitats, from forests to floodplains, from deserts to coastal ecosystems. And as they diversified, they split into many different feeding strategies. Some specialized in herbivory, evolving teeth and digestive systems designed for processing tough vegetation. Others optimized for carnivory, becoming agile predators capable of chasing down prey. This diversity was the beginning of a massive evolutionary explosion: recovery and dominance. By the late Triassic, ecosystems had become far more complex. Species diversity increased, food webs stabilized, and the evolutionary arms race between predators and prey intensified. But dinosaurs still weren't the dominant creatures on Earth yet. They shared their world with synapsids, archosaurs, amphibians, and countless other species. Their rise to dominance would come later, after yet another mass extinction reshaped the planet's ecosystems. But that is a story for another chapter in the Age of Dinosaurs. The rise of dinosaurs wasn't sudden. It was the result of millions of years of recovery, evolution, and adaptation after one of the greatest catastrophes in Earth's history. From the ashes of mass extinction, life rebuilt itself. New ecosystems formed, new species emerged, and eventually, dinosaurs would go on to dominate the planet for over 165 million years. But there are still many mysteries left to uncover about their world, and that's exactly what makes the Age of Dinosaurs so fascinating. If you enjoyed exploring inside the Age of Dinosaurs, do us a favor, like the video, subscribe to the channel, and turn on notifications so you don't miss our next deep dive into Earth's ancient past. Thanks for watching, and we'll see you in the next one.